This is All Things Ansys, a podcast from the technical support staff at PADT, episode 45, talking about using Ansys simulation tools to drive the design of a unique RF antenna concept from a company called FreeFall, as well as news and events from the Ansys world. Greetings from Arizona. This is Eric Miller, one of the owners at PADT, and welcome to our podcast. It's been a busy August, and September is looking even more packed full of events, announcements, and new adventures. So we'd like to thank you for joining us in this little part of our world at PADT, where we talk about all things Ansys. Let's go ahead and get into today's feature, which is an interview that we did back in June. I was able to talk with Stefan O'Doherty from a company called FreeFall. They're down in Tucson, Arizona, and they have a unique way of doing antennas that I'll let him describe in the interview. They're part of the Ansys startup program, and they're using the tool, especially Ansys HFSS, to really try and disrupt their industry. They have some really cool ideas and some unique ways of doing things for both satellite-based and ground-based RF antennas. So let's go ahead and listen to that interview. Like I said, he explains it much better than I do, and see what we can learn from his company's experience using the Ansys toolset. Hi there, I'm joined by Stefan O'Doherty, who is the RF engineer at a company called FreeFall. And it's a really exciting company that's doing some very neat stuff with antennas. And I will not spoil it, but I'll let him explain to you guys what it is. But welcome for joining us here. And where are you calling in from?
Thanks, Eric. I'm actually calling in from Tucson, Arizona.
Great. So I'm up here in Tempe. So you're the usual 2 to 3 degrees cooler down there, I hope, than we are here.
Yep. I think we're balmy 102 today.
Nice. Well, we're here because you guys are part of the Ansys startup program, but more importantly, what you're actually building and doing is really cool. So let's start and talk a little bit about the company itself. So what exactly is it that FreeFall does?
Sure. So we're working on developing new antenna technologies for satellite communications and for upcoming 5G applications. Mm-hmm. It was a startup company that came out of the University of Arizona here. Mm-hmm. One of our founders and chief technical advisor, Chris Walker, is a joint professor in electrical engineering and the astronomy department over at the university, and he spent decades in the field of what's called terahertz astronomy. Oh. You think of it as kind of longer wavelengths than radio astronomy.
Okay.
And some of he works a lot on instrumentation for that field, and some of his more recent concepts he realized he could use to help create new technology for the communications field.
Okay.
So a lot of what he does is balloon-based astronomy down in Antarctica. And one of our founding ideas was that we could take a balloon, basically inflate a balloon and turn it into a telescope. We can do the same and take that technology and apply it to the field of satellite communications.
So that's when you go to the website, which I highly recommend, it's freefallmovingdata.com. You will see some pictures of, I think it's hanging off of a stratospheric balloon, one of your antennas. Is that correct?
Yes. We did actually a piggyback flight we did. Mm-hmm. We got to go out to, NASA has a balloon facility out in New Mexico.
Cool.
And we got to ride on that last year as the initial demonstration of our technology.
So it's a big round balloon that you use as an antenna then.
Yeah, basically it's a alternative to using a parabola. So a lot of standard stations on the ground that would communicate with satellites mm-hmm. Have parabolic dishes. Okay. Parabolas are great because they take all the incoming energy or light and focus it down to a single point.
Right.
The caveat is that you have a very narrow field of view and you have to precisely move your parabola then to maintain a length.
Okay.
Now, a sphere, on the other hand, it doesn't have a focal point, but it has what's called a focal line. And with the right antenna, a kind of a line feed antenna, you can intercept all those rays and you have it. And this gives you the advantage of having a really wide field of view. So we realized that we could utilize this and make it an electronically steerable antenna to basically avoid the need for a mechanical mount. So you get rid of all mechanized movement, and you can electronically steer the beam on this spherical surface.
Very cool, which gets into HFSS. But before we get there, let's learn a little bit about you. What's your background? Where'd you go to school? How'd you end up doing simulation?
Sure. So my initial background was in astronomy for undergrad at the University of Florida. And I was always kind of interested in the instrumentation side of things. For grad school, then I came out here to the University of Arizona and actually got my doctorate degree in the field of optical engineering.
Okay.
So I was working more towards building the telescopes versus using them at that point. Mm-hmm. And as far as that went, Chris, our founder, was actually my advisor in grad school. Great. So I had the task of proving that the spherical reflector could really work.
Yes, which is not a given thing, right? So getting into that, you're explain to those who are not in the antenna world what a steerable antenna is.
Sure. So the easiest, which I mentioned earlier, is a mechanically steerable antenna. Right. So you take your dish, like your DirecTV dish that's on your house, has to be precisely pointed at a satellite. Okay. Now, on the terms of electronically steering the beam, what that means is you have an antenna, and it has different elements within it, and you can start electrically changing the properties or the phase between elements, and they interact differently then. So we can utilize that interaction then is basically how we steer the beam around. So by varying the electrical phases within each element of an antenna, you change how and where the beam is pointing.
Okay. And this is for sending and receiving, or just receiving?
Sending and receiving.
Okay.
So it's equivalent.
Cool. Very cool. So why don't you share, since this is an Ansys podcast, as much as I want to keep talking about these balloons, which Ansys products do you guys use, and what are you using those products for?
Sure. So we are primarily using HFSS, which is the EM simulation software that this provides. And the main point of using it is to characterize and prove that our technology works. And once we have kind of a base design that works for a given antenna, then we have to work on optimizing it for real world applications. So trying to get an understanding for how tight our tolerances need to be. If we see something in lab that doesn't make sense, we can go very few parameters within the simulation software to get a feel to determine if that's root cause or not.
Okay.
So, kind of stuff like that.
Very cool. And so you're using HFSS, and you're basically, if I understand correctly, the surface of the balloon is covered with lots of small antennas that are each tuned to a different phase. Is that correct?
Oh, no. So the antenna is actually more in the central void of the balloon.
Okay.
So like a DirecTV antenna will have a little feed horn at the focus point of that parabola. Okay. With the sphere, it's roughly the same point in space, except it's drawn out to a line. So our antenna fits there, it's a quarter of the way into the balloon, and it is looking down at the balloon surface. So it takes the antenna beam pattern, shoots it towards the sphere, which is a reflector, and that goes off as a nice narrow high gain beam off into space.
Okay. So the balloon portion is just a reflector, and then the different phased horns are in the focal point or focal line.
Yeah, correct.
Okay. So you're talking to a mechanical engineer here. So I always have to think of everything in a physical analogy. So I think I got it now. Go ahead.
One of the analogies that was the original inspiration was the Arecibo Observatory down in Puerto Rico.
Okay.
That's actually a spherical reflector.
Oh.
And before they put in some new spherical correctors, they used to have a big, long line feed there. They would dangle from some cables, and they would physically move that to steer the beam. But that was
Gotcha.
kind of the inspiration. Right?
I did not know that. I just assumed that was a parabola. That's interesting. Okay, cool.
Yep.
Very neat. So getting into the tool itself, how long have you been using HFSS?
So we've been using HFSS now for, I think it's a little under a year.
Okay.
Probably coming up on a year, maybe towards the end of summer. I primarily use it just to kind of view results. We have someone else on staff who does a lot of the simulation work as well.
Good. And what's your favorite feature in the tool so far for you guys, having used it almost a year now?
Actually discovered, or Terrence, who also works on it, discovered a week or two ago this nifty feature that allows him to present the results of our far field pattern, the beam, kind of in animation style. So he can set up the simulation to, say, change the phases to steer our beam around and save the results of that in a nice little movie, which is great for me because I don't have enough time to go look through individual frames, and I just get a nice little GIF that I can view through and see, ooh, okay, I want to see that frame in more detail then. So
very nice. Oh, that's clever. Yeah, okay. If I don't know if you or the users there have thought of what if you could, and the Ansys development does listen to this podcast, so those that are listening, if you could tell them you'd like one feature added to the code, what would that feature be?
Ooh. Yeah, I've been trying to think about that. So, just sometimes it seems it'd be nice to view results while another simulation is running and not have to get too bogged down. Sometimes we have that issue, but that could also be we just need more hardware. So.
The thing that I've found, and it's true of RF engineers as well as fluid dynamicists, is no matter how much hardware we give them, they still need more. So you just build a bigger model. So true. So are you, one of the things we talk about in the Ansys world is driving design with simulation. It sounds like you guys are doing that. You're making design decisions based upon what you're learning from the simulation. Is that true? And has it been, really kind of uncovered anything that was unexpected or solved a really difficult problem?
Yeah, I think it definitely illuminates. We have a complex system here, and there's a general theory of how it works. But for us, it's really unlocked the door to trying to understand the polarization of our antennas and how we can deal with wrangling that polarization. So there's been a lot there. Also, we had our initial base design, and then we went and tried to build it, and we saw some oddities. So then we went back to the simulation and were able to optimize parameters, kind of get an idea for the sensitivity of different variables, which kind of helped us then in how we assembled this or designed parts to hold our antennas.
Cool. That's very, very exciting. Now, this may be not applicable or not, but looking at your website, I know you guys are one of the applications for these antennas in the 5G world. What is special about 5G compared to other communication protocols, and does your product address it in any special way?
So everything we've been talking about so far has been mainly for satellite communications. We have another product group here which deals with the 5G work.
Okay.
And the thing about 5G, true 5G is moving up to higher frequencies. So what you get, like right now, your standard Wi-Fi router you have sitting in your office or at home, that's around 5 gigahertz.
Okay.
So that allows pretty good data transfer. But as you move up to higher frequencies, like a lot of these satellites and 5G are hoping to move up to Ka band, which is 28 gigahertz, you're able to transfer data a lot faster because you can pack more data in for a given frequency there. And so that's really exciting because, people want to stream 4K videos on their cell phone and the reality applications over phones or the remote locations. So that's kind of the drive for the 5G systems. And using kind of ideas from Chris's antennas, we've developed a relatively simple concept that for the 5G world allows us to have a host of antennas at a fraction of the cost and use a fraction of the power that standard systems would have. So we're working on developing that, utilizing, again, ideas he's gotten from his terahertz and radio background and just applying them to the communications industry, trying to get away from the standard status quo of flat panel arrays that are power hungry and have a lot of electronic components.
Gotcha. And you're using HFSS on that side as well?
Yes, when we can spare some time from our other projects.
Okay, cool. Well, so that's something I learned is that this is really a whole disruptive set of technologies that came out of radio astronomy, which I was not aware of. That's pretty cool.
Yes. So.
Yeah, neat. So we have a lot of students that listen to the podcast, and your journey is a little bit different, right? You were a astronomer and then a optics engineer who started using simulation as part of your job. So what would you give advice to someone that's just starting their job and just starting to get into simulation? What have you learned in that journey?
Well, you're never going to get the right answer from simulation right away. There's not a magic button that gives you the answer. And the biggest thing is you have to build some confidence in what you're simulating. So really, you want to jump in and start your complicated system and get the answer. But it's really best to start with building blocks. You know what a textbook answer for X will give you. So you work on the simulation software and make sure you get that. And then you go on to the next step. Because if you don't understand all the knobs of the software, you might be just making up stuff. So that's kind of my initial 2 cents.
No, that's really applicable. That's really good to know because I think we all do that, especially because the software makes it so easy to just read your whole assembly in and apply boundary conditions and run. But especially your device, it sounds very complicated. So probably not good to start there. Yeah.
Yep.
So before we finish up, is there anything else you want to add about the company, about yourself, about your use of HFSS?
Don't think so. I think we covered a lot. So it's been a great help with the startup program to get our feet wet and get these products up and going and simulating them as well. So.
Yeah, and for those who aren't familiar with the startup program, what it basically is Ansys sells the full suite of products, whether it's mechanical, fluids, high-frequency electromagnetics, low-frequency electromagnetics, at a price that is affordable to the startup. So it varies depending on the funding level and success of the startup. So it's a way for the technology to get into these early-stage companies and help them get to market faster and use simulation to drive their design. So we love it. Here at PADT, some of our favorite customers are the startups because they're doing such cool and different things with the software. It's fun. We've been I personally have been modeling turbine blades for over 30 years. I would rather look at something else. So it's good to see what you guys are doing. I think the only other question I have for you guys, if you can share it, what's next for your company? Are you guys have a launch coming up or a pilot program or anything you can share?
We're working on doing a ground station demonstration of our spherical reflector technology, and I think we're kind of aggressively looking for launch opportunities at the end of this year or into the beginning of next year for our inflatable balloon on a CubeSat concept.
Oh, perfect idea. Right, because you've got such limited space on the CubeSat. Yeah.
Exactly.
Cool. So, like I mentioned earlier, the website is freefallmovingdata.com. And if you go to /news or just click on the news in the menu there on the website, you'll see a really cool article that I came across recently from Wired that's linked on their website about a telescope that they're looking at that looks like a giant beach ball, but it kind of explains what we've been talking about for that. And I think if you scroll down a little bit, you can see some other articles and things about what's going on there at Wired, and check out their technology. I think there's a branch for the antennas as well as for the 5G. So for SATCOM and 5G, yes. So cool. There's even a video, which I probably we'll try and link to I'll try and get Trevor to link to that because I think it helps explain what we've been talking about. Because when you're on a podcast, it's hard to explain things without pictures. So, well, cool. I really appreciate your time. I've learned some really neat stuff, and I will continue to watch what you guys are doing and let us know how we can help.
Sounds good. Thanks for your time as well.
Thank you very much. Appreciate it. Okay, welcome back. Every time we talk about 5G and space communications, I learn just a little bit more. There's so much in our world today that really revolves around this idea of radio frequency or RF communication, and the antennas and electronics that go into all that are such a huge part of our modern world. It's good to talk to somebody that's kind of in the thick of it. Even if you're not in the antenna world, I think this is a great example of how you can change what everyone thought was a stable industry. They're using some really cool and neat ideas. It's great to see them as part of our local Arizona startup scene, which PADT is very active in, and especially as one of the companies down in Tucson. That's really doing some incredible stuff, and it's quite a hotbed of high tech down there. So we love doing business with our Tucson friends. So good stuff. Let's take a little bit of a commercial break, and we'll be back with news and other such stuff.
Hi, I'm here to talk about one of the most important services that PADT offers to Ansys users, our training classes. It's a great time to be a simulation engineer. The software tools we use get better with every release. They're easier to use and more powerful. There are so many different physics we can model with ever-increasing accuracy. And all this increasing functionality, along with places we can apply simulation, have one big downside. Existing users need to keep up with new capabilities, and new users need to get up to speed as quickly as possible. That is why PADT offers training and mentoring. For almost 25 years, we've been efficiently teaching engineers how to use Ansys products. Even though there are many online options out there, nothing beats being in a classroom with an expert, where you can learn the theory, understand the principles, and apply them in practical workshops. Our classes can be taught at one of PADT's 5 locations. We can come to your office, or we can set up a class at a rented space. And don't worry, we bring the hardware, the materials, and the expertise. You bring the questions. We can teach standardized classes, or we can customize them to meet your needs. Our courses cover every major Ansys product, and you do not have to purchase your Ansys license from PADT. We can provide training to any user anywhere in the world. Learn the Ansys products you use faster and in greater depth by contacting PADT today. Email joe.woodward@padtinc.com or use info@padtinc.com. If you'd like to talk to a human, call 480-813-4884 and ask to speak to somebody about Ansys training. We're eager to help you learn your products faster and better.
All right. Well, let's go ahead and get started by taking our normal look at the Ansys stock, and it's been doing well. It is at $218.04. This is what's today? It is August 22nd. And it peaked a few days ago above 219, which is very impressive if you consider the volatility in the stock market these days, with all sorts of other stuff going on that have nothing to do with the performance of Ansys. It's weathered most of that and done quite well. Year to date, the Ansys stock is up 58.41%, whereas the S&P 500 is only up 19.47%. So it's really outpacing the broader market indicator. And we talked in the last podcast about the first half and second quarter numbers that Ansys reported. It's a strong company, and it's great for those of us who are users of the tool that they're doing so well. So continue to watch that and see where they go next. In the world of Ansys news, one story I wanted to point out, and you can always just go to the Ansys website and check out their news feed to read these stories that I mentioned, is that Ansys is named to the Fast Company list of the 50 best workplaces for innovators. So what does that mean? We see these lists all the time. Kind of dug into it a little bit. What they're really looking at is if you're an innovative person, if you're somebody that wants to use technology to change your industry or change the world, where's a good place to work? And they felt that Ansys was belonged on that list. It's not one of those things where they rank people from 1 to 50. It's just of the 300 some companies they looked at, Ansys ended up in the top 50 that they chose to highlight. And if you go to the Fast Company website or Google this story about Ansys top innovation, you'll see that there's some pretty impressive companies in that list alongside Ansys. So good company to be in. And I thought that was pretty cool. I've worked with the innovators at Ansys for 30 some years, first as a user and then as a reseller. And very closely with development over many of those years. And I can say it really is a good place to work if you're an innovator. You really get to do some cool, novel things and kind of change the way we do engineering. They've definitely done that over the years. So it was nice to see that recognition. I thought I'd point that out to everybody. They announced 2 partnerships as well that I think are worth noting. They do a lot of these press releases and stories where they say, hey, this cool thing happened. One was with a company called AGI, and they kind of have simulation software for modeling satellites, spacecraft, missiles, rockets, those sort of things, orbiting around the Earth and planets and that sort of thing. And they've kind of partnered with Ansys to have Ansys model the hypersonic portion of reentry. That's really kind of important because to be honest, hypersonic simulation in our CFD products that Ansys represents wasn't necessarily the best on the market. It wasn't an area of focus for many, many, many years. Well, that's changing. We recognize that our customers don't want to go to a third-party niche code to do this regime of the solving, so they're taking a look at Ansys. And there's a lot of other stuff in this announcement with AGI. So if you're in the satellite business or anything that leaves it's not an airplane, but above an airplane, you probably know AGI. So check out the hypersonic reentry modeling that Ansys is doing with them. The next one I want to talk about is Subaru. So Ansys has been announcing many partnerships with companies that are electrifying their automobiles, and the latest one is with Subaru. So those of you who are millennials or live in Denver, and that's a joke, like Subarus, the fact that we're involved with their electrification effort is really cool. And we're big fans of Subaru at PADT. Many of our employees actually drive them, which is why I made that joke. And it'll be cool to see what they come up with and how Ansys helps them get there. So yet another auto company doing electrification using Ansys to drive it. So PADT news, we are going to have a really cool announcement on some new equipment coming down the pipeline that I won't tell you any more about, but look for that in this podcast or in one of our press releases or newsletters. That's a pretty cool thing. We're excited about it. What else do we have to talk about? I think the biggest news since the last time we talked is that PADT was awarded a U.S. Army Phase 1 SBIR grant. And it was for combustor geometry research using 3D printing, simulation, and product development. So this is our 15th SBIR STTR. This one's with the Army. And it's of interest to those of you in the simulation world because we're using Ansys Fluent to model novel geometry for cooling holes in turbine engine combustion liners. The goal is to come up with geometry that keeps the holes from being clogged with sand. This is a project we're doing with Honeywell, which is a very close and special customer of ours. And they, of course, make these combustors for helicopters, jet engines that go on helicopters. And they want to work with us to try out some things on how we can come up with some cool geometry that can only be 3D printed that can keep those holes from getting clogged. So we can't wait to report those results. We just won it. We'll start in a couple months. It's about a 6-month project. So when the phase 1 is done, hopefully we'll maybe get the CFD side of the team on the podcast to talk about what they did and how Fluent helped them do that. It's kind of cool because we had to model the buildup of the stuff that clogs the holes. So it's kind of a unique little tool. And we'll look forward to sharing that with you. We're really excited about it. We're excited about winning 15 of these. We've got a couple more proposals going out shortly, so we hope to have more to report. The other thing we like about this project is we always love it when we can combine simulation with our additive manufacturing experience. So we'll be doing metal 3D printing as part of this whole thing. And there's some other stuff bubbling up. Maybe in a month or two, we'll report about those. Publication-wise, let's take a look at the Ansys blog. I honestly only found one article that I think I'm going to recommend this time. Usually I recommend 3, but they come and they go. Sometimes there's more than 3. Sometimes there's 1. This time there's 1, but it's really cool. It's a story about how engineers are using biomimicry, so trying to model the natural world, to innovate the propulsion of unmanned underwater vehicles. So if you look at, say, how I think it's like a squid or an octopus moves forward, or cuttlefish, I think it actually is. They've got these kind of long fins on the side that go in a wave motion. It's one of the most efficient ways to move through the water. So they're modeling a man-made vehicle that goes underwater that uses the same kind of propulsion system. And I just found that fascinating. It's really cool. Check that out. PADT blog, Ted Harris, our frequent contributor to this podcast, and the head of our technical support team here at PADT. He did a great article that was really useful to me because I wanted to explore this area of Ansys Mechanical, overcoming convergence difficulties with automatic remeshing. So it's nonlinear adaptive regions where you can say, hey, when things get a little crazy mesh-wise, go ahead and automatically remesh it, converge on the new mesh, and then move forward with your nonlinear solve. So if you haven't tried automatic remeshing, give this article a read and try it out. Even if you are using it, there might be some hints in there that he uncovered while trying to get it done. Event-wise, we've got our next webinar is going to be this coming Wednesday after this podcast comes out, August 28th. That's 11 a.m., Phoenix time, which is when we usually do them. And this one is High Frequency Electromagnetics Update, Ansys 2019 R2. So we'll be talking with our high frequency team, which is very appropriate with our discussion today on antennas. So we'll be talking about what's new in the latest release from Ansys. And there's actually quite a bit, as you would imagine. So look forward to listening to that webinar. And with all of our webinars, you can go to www.brighttalk.com and just search for PADT, and you can see all the recordings there as well as upcoming ones. Please do register, and then you can listen to them live or at your leisure. And you can also, if you don't want to go to brighttalk.com, you can go to our website, padtinc.com/events. And any of the stuff we talk about in the events section, you can click on the information or registration link that's with that. And speaking of upcoming events, we got a lot coming up. Like I said, in September is very busy, and let me go through these very quickly. The first one is we'll be attending the Rocky Mountain Life Science Investor and Partnering Conference, which is in Vail, Colorado this year. Darn it. I'm going to really suffer. I'm going to that one. That's September 4th and 5th. The event is mostly on the day of the 5th, and we'll be looking at a lot of cool startups in the life sciences area. The next event is going to be Manufacturing Tech Council, which is a group for advanced manufacturing. They're doing a panel on advances in additive manufacturing on September 10th. That's 10 a.m. Phoenix time. And I'm going to be on that panel. I'm going to be talking about 3D printing and what kind of our journey at PADT in the world of additive manufacturing and where we see it going. And we've got some great guests on that panel. They're going to talk about how their technology is changing additive manufacturing as well. I'll try and get a plug-in for simulation while I'm on there talking about 3D printing. And like I mentioned earlier, go to padtinc.com/events to register for this. There's a link there on that page. That's not something we're hosting, so follow that link. I'll also be, for those of you who might be listening from New Mexico, I'm going to be at the annual New Mexico Tech Council Experience It conference. It's their annual get-together for the Tech Council. It's going to be at the Sandia Resort and Casino on September 13th. It's an all-day event. I'll be at the VIP mixer the night before and the tech crawl, I guess they call it, the evening of the 13th. But I'll be speaking on a panel about additive manufacturing and simulation, hopefully, and then also speaking around on other topics and at a table that PADT will have at the event. So I'm looking forward to meeting any of you who are out there in New Mexico and want to come out to the day for the Tech Council. After that, we've got a STEM event on the 17th. I'll be on a panel from 10:30 to 11:30 talking about my experience moving from being a technical person to being a business owner. And then I'll also be talking with students one-on-one and kind of a speed dating thing for STEM students from 11:30 to 12:30. And then the final event, it's the most important event of September, is the 2019 Colorado Additive Manufacturing Day. So anyone I offended in Colorado by making my Subaru joke, you can come on down to you can drive your Subaru down to a artisan craftsman brewery in Littleton. It's called Blind Faith Brewing. This is where we always have this event. This is the third year we've done it, and it's a great location. It's beautiful there on the side of the river in Littleton. So do check that out. Do register for that. It's on the 25th, and it goes from 1 p.m. to 7 p.m. there in Littleton, Colorado. And we have a great agenda full of speakers. We'll be talking about Ansys will be there talking about their additive solutions. We've got customers like Lockheed. We've got experts from local universities talking. It's a great event. Of course, Stratasys will be there as well as Desktop Metal and the other companies we work with, Zeiss. So if you're in Colorado, you should have gotten an invitation to this because we've been telling everybody for a while now. But if not, go to our events page, RSVP, so we have enough pizza for everybody. So do check that out. That's on the 25th in Denver, or in Littleton, actually, which is south of Denver. So do check that out if you're in the area. We'd love to see you. It's a great time. It's my favorite, our second favorite gathering of the year. We usually have an open house here in Tempe, and this is my second favorite one. So thank you. That's it. I got nothing else to talk about. Don't forget to subscribe at www.padtinc.com/opt-in and spread the word about our podcast. Our readership is growing. We hope you liked our two-part episode. Episode 43 and 44 were a two-part episode about Granta, which is a new acquisition by Ansys that we're really excited about. If you haven't listened to it, go back and listen to it. It's going to change how you deal with materials. And as always, don't hesitate to reach out. We'd love to hear from everybody. Thank you very much. Thank you for joining us for the All Things Ansys podcast, episode 45. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.